we'll discuss the vapor absorption refrigeration system. In the previous class, we discussed vapor compression refrigeration system. In that case, the refrigerant vapor was compressed by using one compressor. But in this case, the compressor is not used. There is no compressor in this refrigeration system, and in place of this compression there will be only absorption, and this absorption and some additional facility will help the compression of the refrigerant vapor, and that we'll discuss in today's class. Okay, so what is vapor absorption refrigeration system? Let us discuss one interesting phenomena. Suppose we have some water in a container. Okay, say we have some water in a container, and if there are some ammonia vapor, say, then what will happen? The ammonia will dissolve with the water, and not only that, it will also produce some heat during this absorption process. Water immediately absorbs the ammonia vapor or ammonia, and in that process heat is released during this reaction. So basically this is a chemical reaction, ammonia vapor, and the reaction goes like this. So one molecule of water combined with one molecule of ammonia, that will produce ammonium hydroxide. Okay, this is called ammonia solution, because of the combination or absorption of ammonia by water. This solution is called aqua ammonia solution, and sometimes we call it aqueous ammonium. Also we simply call it ammonia solution. That means solution of water with ammonia, but we'll use aqua or aqueous. Aqua means water, so aqua ammonium solution, or simply we can say aqua ammonia. Because of the chemical reaction with water, chemical reaction of water and ammonia, we get aqua ammonia, and this reaction is exothermic reaction. So you are already familiar with the term exothermic in the chemistry. So what is an exothermic reaction? The chemical reaction in which heat is produced or generated due to the chemical reaction. There are some other type of reaction that is opposite, which is called the endothermic reaction, in which we have to add heat from the outside, then only the chemical reaction takes place. But in this case, the reaction is exothermic reaction, so heat is released due to the chemical reaction. So definitely when water and ammonia dissolve, then the temperature will increase. That means heat is generated. This principle will be used in our discussion in our absorption refrigeration system, and this is also called ammonia absorption refrigeration system if we use ammonia as refrigerant. So what is the role of ammonia in this case? This is the refrigerant. So that is why it is also called ammonia absorption refrigeration system if we use ammonia as refrigerant and water as absorbent. Water will be called absorbent. Okay, the most interesting thing is that ammonia has very strong affinity to water, or we can say water has strong affinity for ammonia, and because of this ammonia dissolves in water and we get aqua ammonia. Okay, so absorption is more, that means absorption efficiency is more at low temperature. if the water temperature is low, then water will immediately absorb ammonia. That means efficient absorption. And if the temperature is high, then absorption will be less. So that is also required in absorption refrigeration system. Now, if concentration of ammonia is high, that means there is more ammonia, less water, then that type of solution is called strong aqueous solution or strong ammonia solution or strong aqua ammonia. And if the amount or concentration of ammonia is less in water, then that we call weak ammonia solution or weak aqua ammonia. Okay, with this understanding, we'll try to explain the principle of Vapour absorption refrigeration system. Suppose this is a container and we call it a generator, and this is like a steam generator or boiler in which we take strong ammonia solution. Just now I have explained what is strong ammonia solution. That means concentration of ammonia is very high, that we call the strong ammonia solution. If we take the strong ammonia solution in a boiler or generator and we add heat to this generator or boiler, then like the production of steam, this generator will produce ammonia vapor from this strong ammonia solution. So this ammonia vapor will go to a component called analyzer, and this analyzer will absorb the water vapor if present with the ammonia vapor. So sometimes this ammonia vapor, ammonia plus water vapor, it may contain some ammonia as well as water vapor. The water vapor will be, water part will be absorbed by the analyzer. It will analyze if there is any water vapor and it will absorb those water vapor from the ammonia vapor. Okay, so but still there may still be some water vapor present with the ammonia vapor, and that is why it is passed through a rectifier. So this rectifier again removes water from ammonia. If there is any more water vapor or water particles, those will be removed by the rectifier. So basically what will happen, the ammonia vapor along with the water vapor will come through this, and the water vapor will as well as ammonia vapor will strike this obstruction, and due to this obstruction the water vapor will lose its momentum or some of its energy, and if it loses some of its energy, that means it loses some heat energy, and that way that will become water. That means it will be condensed, and if water is condensed, then that will settle down at the bottom of the rectifier. What will go out of the rectifier? Only ammonia vapor will go from the rectifier. From rectifier, only this is ammonia vapor. So there will be no more water vapor. Only ammonia vapor will go to the condenser. And as we all know, the function of a condenser is to convert one vapor to the liquid stage. So this ammonia vapor will be condensed with some cooling arrangement definitely. It may be water cool or air cool also. So because of the cooling, the ammonia vapor will become ammonia liquid. Okay, it will become now liquid. Now this liquid or ammonia vapor has high pressure. Now how we get the high pressure ammonia vapor? Because this is a generator, high pressure steam generator. Steam means ammonia vapor generator. So this ammonia vapor is generated at high pressure like a high pressure boiler. So this ammonia has high pressure. All this has high pressure. So definitely after condensation will also there will be high pressure. So this pressure has to be reduced or it will has to be expanded. So that is done by an expansion valve. We also call it throttle valve, but basically this function is to expansion. We call it expansion valve, and throttle valve is an expansion valve. So what is the function of the expansion valve or throttle valve? To reduce the pressure. It will reduce the pressure and we will get low pressure. And as we know, if we reduce the pressure or expand some gas, the temperature as well as pressure decreases. So temperature of ammonia liquid will decrease as well as the pressure. So low pressure, low temperature ammonia liquid will go to the evaporator. So what is an evaporator? Basically this is the refrigerator. Okay. So this ammonia liquid, this is now ammonia liquid. Low pressure, low temperature ammonia liquid will absorb the latent heat of vaporization from the refrigerator or evaporator, and it will get evaporated. If any liquid absorbs the latent heat of vaporization, then that liquid become gaseous or vapor. So from evaporator what will go out? The ammonia, pure ammonia vapor will go out. So what will go out of this? This is ammonia vapor. Ammonia vapor will be go to the absorber. Now what is a absorber? In absorber, that principle is used. The water will absorb the ammonia because of the strong affinity of water towards the ammonia. The absorber is basically what? It sprays the water from the top, sprinkle the water from the top, and ammonia vapor will go from the bottom. And because of the high affinity of water towards the ammonia, the water will absorb the ammonia. And remember, at the same time, there will be some heat released due to this chemical reaction. So we have to arrange some cooling system with this. So this is, for this we will need some cooling system to keep the absorber cool, because that will increase the absorption. Now what we get in the absorber? Remember, now absorber has strong ammonia solution because water absorbs the ammonia. Now it becomes a solution, and that is a strong ammonia solution. So this strong ammonia solution will be pumped by this pump. This pump will take the strong ammonia solution from the absorber and it will go through a heat exchanger, and again it will go to the generator. This is strong ammonia solution. Now what will enter into the generator? Strong ammonia solution. Now this strong ammonia solution, what is inside this? The strong ammonia solution inside the generator. But remember, generator is continuously producing ammonia vapor. Is it true? Generator is continuously generating the ammonia vapor. So at the bottom of the generator there will be weak ammonia solution. Weak ammonia solution, because ammonia is going out as an ammonia vapor. So there will be less concentration of ammonia in the solution, and this weak ammonia solution will taken from the bottom and it will be pumped through this is a pump which will take the weak ammonia solution. And so what is this? Hot weak ammonia solution, cold ammonia solution, because it was cooled in the absorber. this cold ammonia solution will come as hot and strong ammonia solution. It will go to the generator, and from generator the hot but weak ammonia solution will come, and here the heat transfer, heat exchange takes place, and it will become, and it will enter into the absorber again. So basically, what is weak ammonia solution? There is very little amount of ammonia and most of those are water. So we can say this is water only. So this weak ammonia solution will enter into the absorber and it will be sprinkling down to the absorber where the absorption takes place. Okay, so this way the whole cycle takes place. So where from the low pressure starts, from here it will be low pressure. Up to this point it is high pressure. From where it is high pressure? From generator onwards, because generator is producing high pressure ammonia vapor, and that pressure will decrease in the throttle valve. So this is the working principle of your vapor absorption refrigeration system. Now you can see the difference with the vapor absorption and vapor compression refrigeration system. In the previous class we discussed vapor compression refrigeration system. In this example the compressor is not there. Have you seen any compressor here? There is no compressor. Now in place of compressor, what is present in this system? What is the arrangement that increases the pressure of the refrigerant? So this generator along with the absorber serves the purpose of a compressor. Not compressor, the function is like a compressor, because compressor increases the pressure. Now in this case, generator increases the pressure, but with generator we have some heat exchanger, pump and absorber. This whole components, generator, heat exchanger, pump and absorber, replaces the compressor of a vapor compression refrigeration system. So basically this is the vapor absorption refrigeration system.